All right, good morning. Continuing on with what we have been working with inequations, we have most recently crossed over to inequalities, both general and absolute value. And delving further into this remaining topic, we have from page 102. And we have for number 9, okay, we're looking at determining both the graphing solution, the set builder solution, as well as the interval solution. And in number 9, okay, so we have an inequality, okay, where we have that negative 2x minus 5, okay, is greater than 17. And looking at solving for this inequality, okay, we have the single variable term negative 2x, and what I can do is, just as I would an equation in solving for x, I can isolate the negative 2x upon adding 5 to both ends. So we're going to have by itself negative 2x on the left, and to the right we're going to have the number 22. All right, and now we have for x, okay, we have the negative coefficient minus 2, and taking care of what we have, if I divide by negative 2, and I'm going to emphasize this point, okay, if you're multiplying or dividing by a negative, the direction of the inequality changes, okay, so okay, so again, the inequality direction changes when multiplying or dividing by a negative. Not adding or subtracting, but multiplying or dividing. Had I divided by 2, okay, I would still have the inequality to be greater than, but with division by a negative, okay, so we're going from greater than to less than. Okay, so we have, at least for the inequality solution, okay, so we have that x is going to be less than negative 11. Okay. So this is our inequality solution. Now, in terms of the graphing solution, okay, what you're going to have here, I'm going to do a bit of a sketch. Okay, so we have just emphasizing, okay, so have x is less than negative 11. So if you were to envision a number line, you would have like a hole or a circle on negative 11. And from this, okay, you have what's going to be a ray that's going to go continuously to the left. And you're going to go continuously to negative infinity. And in terms of what is referred to as the set builder notation, for set builder notation, okay, you're going to have what we refer to as braces as the grouping symbols. And you're going to essentially restate the inequality. Now, the set builder notation, this will be where you had the set of all values of x such that, and then we have completing out with the inequality. We have the x is less than negative 11. And in terms of what we have for the interval result, okay, so again, you have going from negative infinity. Okay, so again, all infinities positive and negative, okay, will be in parentheses, again, because negative and positive infinity are not stopping points. And we have approaching but not including negative 11, and because of the exclusion of negative 11, okay, that number is also contained in parentheses. All right, so you have the three modes of solutions, okay, with the graphing, the set builder notation, and the interval notation. So those are three distinct ways of communicating that x is less than negative 11. All right, now for what we have in the case of number 10, okay, so we have an inequality, and this time we have looking at solving for t. And we have for this one, okay, we have negative 8t plus 1 is less than 17. Again, just like negative 2x, I'm going to isolate negative 8t. Okay, and this time I'm going to take 1 away from both sides. So we're going to have negative 8t is less than 16. Okay, and I'm going to follow through. Now I have with division. And so I'm back to where I have, again, dividing by negative 8. And if I had divided by positive 8, the inequality direction would still remain as less than. But since I'm dividing by a negative, okay, so I'm going from, again, from less than to greater than. So you have the direction of the inequality change, bit of history to repeat. And so we have for t, negative 8t over negative 8 becomes t. And 16 divided by negative 8 is going to be negative 2. So we have for the inequality solution, okay, we're going to have that t is greater than negative 2. And in terms of what we have in the graph, okay, so if you were to envision a number line, okay, so we're starting right at negative 2, and again, we don't have the equal sign and the inequality, so we still have an open circle or parenthesis. Now for t is greater than negative 2, okay, the greater than signals that we're going to have motion continuously to the right. And this time we're going to have the upper limit approaching positive infinity. And for what we have in the case of the set builder notation, again, so this time we're going to have the set of all values in the variable t, and the vertical slash is read such that, and then we have closing out with the inequality. We have that t is greater than negative 2. And in terms of the interval solution, okay, so you have starting from that which is greater than negative 2. Okay. So we're not including negative 2, so we have that contained in a parenthesis. And again, we have approaching infinity. Okay, and so that'll be the notation for what we have in the interval solution. All right, now, in looking at what we have for the next mentioned item, and we have with number 16. Okay, so we're kind of shifting gears, okay, going from solving for x to solving for t, and now we're looking at solving for m. Okay, and this time we have the variable expression on the right hand side of the inequality. So here we have negative 14 is less than 3 times the quantity of m minus 7 followed by the addition of 7. So here we have negative 14 is less than, and we have distributing 3 over the quantity of m minus 7. So we have 3m minus 21 followed by the addition of 7. Okay. And so just gathering the constants on the right hand side, so we have negative 14 is less than 3m, and have negative 21 plus 7, which will be minus 14. Okay. And now I'm going to isolate, okay, the variable term 3m. So we have negative 14 is less than 3m minus 14. So I'm going to add 14 to both sides. And here we have additive inverses, and when combining, okay, additive inverses will cancel. Okay, so I have that 0 is less than 3m. Again, we have the variable term on the right hand side of the inequality, but what I can do is that I'll just do it later. Okay, so we have 0 is less than 3m. Now, to take care of the 3, I have division. This time around, I'm dividing by a positive as opposed to a negative. So the direction of the inequality is fixed. Had I divided by negative 3, the direction would have changed from less than to greater than. But here we have 0 divided by 3 is 0, is less than 3m divided by 3, which is going to be m. Okay, now what I'm going to do here is that I'm going to adjust, okay, this inequality with the variable on the left hand side. So 0 is less than m. This is going to be the same logical equivalence. To say that 0 is less than m is the same as saying that m is greater than 0. Okay, so you still have the inequality. Okay, so you have that m is greater than 0. Logically equivalent to 0 is less than m. And for what we have in terms of graphing, if you were to envision, say, a number line you have on 0, okay, well, it's going to be a hole or a circle. And for greater than, we'll have the appearance of yet another ray, okay, and we have going continuously to the right. Okay, so you have for the upper limit, okay, you have approaching infinity. And for other representations of the solution, okay, we have for the set builder form, okay, this time we have the set of all values in the variable m. We have such that, and then we complete the statement with the inequality. So you have such that m is greater than 0. And once again, we have for the interval solution, okay, so we have between 0 and infinity. And again, because 0 is not included, we maintain the use of the parenthesis. And again, infinity is boundless, and that is also contained in the parenthesis. So we have for the interval solution, you have parentheses around 0 and infinity. All right. Now, we have in terms of crossing over, okay, and where we have in numbers 27 and 28, okay, just looking at what we have with the terminologies, with the words and as well as or. Okay, say we have inequality statements. So you have a pair of inequality statements. Okay, now and this can be referring to what is common between the inequalities. Or in other words, what is shared in common between the inequalities. Now for the word or, now with the term or, if you were to represent, okay, you're looking at combining everything that exists between the inequalities. So you're looking at combining everything, shared or not. Between the inequalities. Okay. And just taking, let's say for what we have with number 27. Okay, now we have in this particular layout. Okay, so you have we have that x is less than 4. As well as x is greater than or equal to -2. And just looking at, say, just graphical representations. Okay, so we have with x is less than 4. Along with x is greater than or equal to -2. You're just sort of doing a sketch here. So you have 4, -2. Okay, now for x is less than 4. So you have an open circle. Again, 4 is not included. And we have a ray that is going to go to the left. And for x is greater than or equal to -2. So you have with the equal sign. Now on -2 is going to be a closed point. And we have a ray that's going to go continuously to the right. Now, in terms of the linking word that exists, okay, between the inequalities. Okay, so if I have that x is less than 4, and we have that x is greater than or equal to -2. Okay. What's going to happen here now with the word and? You're limiting to what will be shared in common between the inequalities. So for what we're going to have in this case, let's see. For what is shared. Okay, so you have x is less than 4, x is greater than or equal to -2. Okay, so you have the graphs are going to be crisscrossing each other. And in terms of what is going to be shared, so anything greater than or equal to -2 but less than 4 is going to be present in both graphs. Okay. Everything else, that which is greater than 4, anything that is less than -2, those are going to be not common to both of these inequalities. So just for what both of these graphs as described by the inequalities, okay, they're going to share those values that will be between -2 inclusive and 4 exclusive. And just for the interval solution on these, Okay, so we have going from and including -2, and this time we're going to have the bracket surrounding -2, and we have approaching but still not including the number 4. Okay. And I'll just mention, okay, if I had, it didn't ask for this, but if I had like a set builder description, this would be whereupon you would have the set of all values of x such that, and notice we have for this line segment, you can combine these inequality statements and make into a compound inequality. So you can see we have the set of all values of x such that -2 is less than or equal to x, which in turn is going to be less than 4. Now we have in terms of and, so you have x is less than 4 or x is greater than or equal to -2. And again, it's just going to link everything together. And so, what's going to arise in this case is that you're going to have continuous activity on both ends. And guess what? When we looked at just the set of terms common to both inequalities, okay, we were still excluding 4. But since I'm including everything greater than or equal to -2 and everything less than 4, everything is tied in together. And guess what? So you have running continuously between negative and positive infinity. Again, just for the interval notation, okay, when you have a set of all values of x such that x is less than 4 or x is greater than or equal to -2, once you unite everything, we have, again, set of all real numbers, and we have the interval notation with negative and positive infinity enclosed in parentheses. And I'm just mentioning for the set builder notation, it's like, how would I write the set of all real numbers in this case? And one way you can go about this is that we can say we have a set of all values of x such that x, you have what looks like an E symbol. This is the Greek letter epsilon. And just for this portion here, this is going to be referencing is an element of all real numbers. There we go. Okay, so with the linking word and, again, you're limiting to what will be shared in common between the inequalities. With or, you're putting everything on the table, regardless of what is shared or not between the features. Now, for what we have in the case of, say, for number 28, okay, this time we have our inequalities. Okay, we have in the variable y. Okay, so you have that y, okay, is less than or equal to -2. And we also have that y is greater than -5. Okay. And so for what we will have here, okay, so you have, okay, we have -2. And with the equal sign, you have a close point. Okay, and then we have the rest of the activity you have to be less than. And for y is greater than -5. So on -5, you have an open circle. Greater than, you have array going continuously to the right. And again, just taking what we have, okay, so for y is less than or equal to -2 and y is greater than -5. Okay, so again, you're looking at what will be shared in common. Let's see here. Yeah, so you have open circle on -5 and a closed point on -2. Again, so we're going to have a line segment. And the way that you can ultimately define this, okay, notice we have uniting what we have common between the graphs. Okay, so you can say we have -5 is less than x, which in turn will be less than or equal to -2. And for the interval solution, okay, so we have starting again between -5 and -2, and just for the closing out, -5 is not included, so we maintain the parenthesis. -2 included. In fact, there should be y. Okay, so -2 is included, and that is going to be bracketed. And for the set builder form, okay, so we had the set of all values of y, such that we have that -5 is less than y, which in turn is going to be less than or equal to -2. And just taking, now, so if we had the y is less than or equal to -2, or we had that y is greater than -5. Guess what? We're going to have this bit of history to repeat, combining everything. So everything less than or equal to -2, then everything greater than -5. We're going to have the set of all real numbers once again. And with this approach, okay, it turns out that -5 is going to be included, as well as -2, everything in between, and everything before and after -5 and -2 respectively. So again, we have with the interval solution, again, we had the set of all real numbers indicated by parentheses enclosing negative and positive infinity. And for what we have, once again, the set of, in the set notation with the set builder form, okay, so we're going to have the set of all values of y. And again, just going back to the notation you have with the epsilon and the r. So we had the set of all elements y such that y is an element of all real numbers. Right. So that is the fine line that divides, okay, the terms and or. And you're looking at just what will be shared in common, or you're just looking at taking everything between the inequalities regardless of what is shared or not. And now for what we have, just looking into absolute value. Okay, so again, with and, you're looking at what would be shared in common. Okay. And now with the or, you're looking at what will be shared plus what is not shared. Think of it sort of like this. You might have, let's say you have 30 students. 30 students, okay, and you got, out of those 30 students, 20 are attending JCC, but guess what? 20 of the same 30 students happen to be attending Wake Tech. So you got 30 students, like a pool of 30 students. So 20 are attending JCC, and within that pool of 20 students, you got 20 who are attending Wake Tech. Okay, and the way that this can be framed is that, okay, so like those students who are attending JCC or Wake Tech, that's going to be all 30 students. But if you're looking at that set of students, okay, who happen to be attending both JCC and Wake Tech, it will be like those 10 students, like 10 students, say, are attending both JCC and Wake Tech. Okay. So in other words, you have 30 students, okay, if say they're, you have like, attending JCC or Wake Tech, you're looking at just the whole set of 30 students. But if you're looking at those who are attending, like maybe taking some load at JCC, some, and taking some load at Wake Tech, it's not going to be all 30 students, but just that pool of students that happen to be attending both institutions within the same semester. So with the word and, okay, you're looking at just that set shared in common, whereas with or, you're looking at everything regardless of what is shared or not. Okay, all right. So for which to solve for, you'll be given the linking word like or and. If you don't have that put up right yet, I'll show you in just a moment. Yeah. So we have with the absolute value of x equal to k. Okay, so you have that x is equal to plus or minus k, which we have at k and negative k. And for what we have in the next case, all right, so we have if k is non-negative and we have the absolute value of x is less than k, then you're going to have that negative k is less than x, okay, which in turn is going to be less than k. Okay, and so your interval notation, you have negative k and k. All right, so just going back, okay, let me put it this way: if you have like the and statement, the result's going to be a compound inequality, and just kind of going back to your question. So this is like saying that x is greater than negative k and x is less than k. And this is the consolidated statement for this. So x is greater than negative k, same logical equivalent as saying that negative k is less than x, and then we have in turn x is less than k. Okay, now if we have that absolute value of x is less than or equal to k, then you have negative k is less than or equal to x, okay, which in turn is going to be less than or equal to k. Now the interval notation would be like brackets enclosing the negative and the positive k. So we're going to have in this one case. So this would be like saying that x is greater than or equal to negative k, and that x is less than or equal to k. All right. Now we have going in the other direction. So if I have that the absolute value of x is less than k, what's going to happen here is that you're going to have going in separate directions, and this is where you're going to have your or statements to arise. Okay, so if the absolute value of x is less than k, and I'll just use this notation, color coding, you're going to have that x is less than negative k, or that x is greater than k. So you have a bit of a split, and the interval notation for this, you have, okay, again, between negative infinity and negative k, that is its own interval, and then you have x is greater than k, and that's going to be detached from the first interval. Okay, and that U symbol again is going to be in reference to union. And let me, my bad here. So yeah, I'm increasingly negative, increasingly positive. Say absolute value of x is greater than k. All right, so, and if I have that, the absolute value of x is greater than or equal to k, then we're going to have the x is less than or equal to negative k, or that x is greater than or equal to k. And again, just for the interval notation equivalent, very much like the prior statement, okay, this time we have negative and positive k will be included within each section. Okay, and in terms of taking what we have with absolute value inequality statements, and say we have from the group, okay, if we have, let's say, for number 48, okay, so we got this time we have in the variable y, okay, so you have 2 times the absolute value of 7 minus y, followed by the addition of 1, okay, is less than 17. And again, so I do not treat the absolute value grouping symbols as I would parentheses or brackets. So I'm not going to distribute multiplication of 2 over the difference between 7 and y. Okay. And if I take 1 away, so if I take 1 away from both sides, so I have 2 times the absolute value of 7 minus y is going to be less than 16. And we have with division by 2. Again, so I'm dividing by a positive number. So the direction of the inequality remains as less than. So now with division by 2, okay, so this comes down to the absolute value of 7 minus y is going to be less than 8. Okay, and now just looking at what we have within the framework. Okay, so if you notice, okay, you have absolute value of x is represented by the absolute value of 7 minus y, and k is represented by 8. So looking at, okay, like less than k, okay, it'll be, this inequality will be of the format of the second case, where we had the first absolute value inequality scenario that is presented. Okay. Okay, so this statement is analogous to what we have with the absolute value of x is less than k. So what do I do with 7 minus y upon removal of the absolute value bars? Well, I'm going to situate 7 minus y between negative and positive 8. Okay, so in this setup, so we have that negative 8 is less than 7 minus y, which in turn is going to be less than 8. Okay. So I have this compound inequality, and I am going to isolate the y term. Okay, so the y term right now we have at 7, within 7 minus y, so I'm going to isolate the negative y. So I'm going to remove the 7, and this will affect all sections of this compound inequality. So right now I have negative 8 minus 7. Okay, so this will become negative 15. And we have is less than negative y, which in turn is going to be less than 8 minus 7, which is 1. And again, I'm solving for y, okay, not negative y. So what I need to do here, I can either multiply or divide by negative 1. And I'll just multiply by negative 1 throughout. Once again, if I multiply or divide by a negative, now the direction of the inequality is going to change. So here, negative 1 times negative 15, negative 1 times negative 15 is a positive 15. Negative 1 times negative y becomes y. In turn, negative 1 times 1, okay, is negative 1. Okay, so got 15 is greater than y is greater than negative 1. Okay, and if I write this going from smallest to largest value, so just kind of flipping but maintaining the logical equivalence. Okay, y is greater than negative 1, same as negative 1 is less than y. 15 is greater than y is the same logically as y is less than 15. And so for what we're going to have in the end result is that for the interval solution, okay, so you have minimum to maximum. So you have between negative 1 and 15. And since the inequality statement does not include equal signs, that means negative 1 is less than y will be in the parenthesis. Y is less than 15 also signals that 15 is going to be in the parenthesis as well. So the grouping symbols will exclusively be parentheses. Right. And now, for what we have in the case of, say for number 58, okay, so this time we're looking at solving in terms of the variable d. And in this one, okay, so we have that 15 is less than what we have, okay, between the sum of the absolute value of negative 2d plus, make that negative 2d minus 3 and 6. All right, so 15 is less than the absolute value of negative 2d minus 3, followed by the addition of 6. And I'm going to get the absolute value term by itself. So I'm going to take 6 away from both sides. (15 minus 6 is 9, and I have that 9 is less than the absolute value of negative 2d minus 3. Okay, so I have a single absolute value term compared with a constant, and what I'm going to do here is I'm going to just change the positions, okay, and maintain the logical consistency. So I'm not multiplying or dividing by negative. What I'm doing is I'm just going to just rewrite this with the absolute value term on the left. So you have 9 is less than the absolute value of negative 2d minus 3 is going to be the same logically as the absolute value of negative 2d minus 3 is greater than 9. And just looking at how to follow through, okay, so you have absolute value term greater than k. Guess what? We have this is going to be, this setup is going to be analogous to case number 4. We have x represented by negative 2d minus 3. And if its absolute value is greater than what represents k, then what do I do with negative 2d minus 3? Well, this is where we're going to have our separate inequality statements upon removing the absolute value symbols. Okay, so for x is less than negative k, this would be whereupon we would have negative 2d minus 3 is going to be less than negative 9, or we're going to have negative 2d minus 3 is greater than k, where we have negative 2d minus 3 is going to be greater than 9. So again, absolute value of x greater than k, x is less than negative k, or x is greater than k, where we have x represented by, again, negative 2d minus 3, k represented by 9. And in terms of looking at solving, what we have for the variable d, so working with the respective inequalities, so we have for negative 2d minus 3 is less than negative 9. If I isolate the negative 2d, so I have with adding 3, okay, so we have negative 2d is less than negative 6. And this time we have negative 2d divided by negative 2. And because I'm dividing by a negative, again, the direction of this inequality will change. So we're going to have that d is greater than positive 3. So part of the solution to d is going to be greater than 3. And the other part, this will stem from the other established inequality. So we have with negative 2d minus 3 is greater than 9. So if I isolate this d term, so we have adding 3 to both sides. So we're going to have that negative 2d is greater than 12. And once again, dividing the d term by negative 2. Again, if you multiply or divide by negative, the direction of the inequality changes, this time going from greater than to less than. And so we have, in this case, we're going to have that d is less than negative 6. Okay. So we have at the extremes. Okay, so we have d is greater than 3, or that d is going to be less than negative 6, and just providing a bit of a visual. And without writing all of the numbers, in case you have negative 6 is involved, 3 involved. Now for D is greater than 3. Okay, you have graphing, you have D is greater than 3, so you're going to have an open circle or hole on 3, and you have the activity going continuously to the right. Again, we have approaching infinity. And for D is less than -6. So again, without the equal sign, there's going to be also a hole on -6. And you're going to have a ray that will go continuously to the left. And this lower limit, okay, we have approaching negative infinity. And in terms of the interval solution, okay, the left-hand side is in reference to D is less than -6. For the interval solution, okay, so you have going from negative infinity, approaching but not including -6. And then we have or, we have at the other end of the spectrum, we have that D is greater than 3. And so we have symbolically, we have parenthesis around 3. And we have approaching infinity, and again, all infinities, positive and negative, remain in parentheses. So this will be the interval solution of what we have for this particular inequality statement. All right, and now let's say that for just separate cases, and we'll say that we have, let's see, in case that there's like a special situation, and we'll say that from page 103. And we'll say that we've got in the case of 49, okay, so we have, so you got 2 times, okay, the absolute value of x plus 3, followed by the subtraction of 4 is greater than or equal to 6, okay. Okay, and if I isolate, again, the absolute value term, so we have upon adding 4 to both sides, so now we come down to 2 times, okay, the absolute value of x plus 3 is going to be greater than or equal to 10. Now we have with isolating the absolute value of x plus 3. So we have with division by 2. So I'm now dividing by a positive 2. So the direction remains fixed. So this will come down to the absolute value of x plus 3 is greater than or equal to 5. Okay, so we're back in terrain. Okay, so we have the equivalent of the absolute value of x is greater than or equal to k. So you're going to have a couple of inequalities with the equal sign that will branch out. So for representation of x is less than or equal to -k, upon removal of the absolute value bars, okay, so we have at the lower end, we're going to have the x plus 3 is less than or equal to -5, or we have at the upper end, okay, we have the x plus 3 is greater than or equal to 5. And just looking at solving, okay, these inequalities. Okay, so we have for x plus 3 is less than or equal to negative 5. Okay, so if I take 3 away from both sides, so we have that x is less than or equal to negative 8. Now for x plus 3 is greater than or equal to 5. Again, if I take 3 away from both sides of the inequality, so we have that x is greater than or equal to 2. Okay, so we have two directions that are distinct upon which x will be heading. Either you have x is less than or equal to 8, negative 8, or that x is greater than or equal to 2. And again, just looking at what we have. Okay, so we have with our values of interest. Okay, so we have negative 8 and positive 2. X is less than or equal to negative 8, so with the equal sign, negative 8 is included. And we have the rest, you have to be less than. Alright, and then we have with the upper ends, okay, x is greater than or equal to 2, so you have a close point on 2. And the rest of the values you have to be greater than, so you have a ray that's going to go continuously out to the right. And we have approaching infinity, and we have for the interval outcome. Okay, so we have two distinct entities. And for the representation of x is less than or equal to negative 8, so we have going from negative infinity, approaching and including negative 8, and the minus 8 is going to be enclosed in the bracket. And for x is greater than or equal to 2. Okay, so we have a bracket around the 2, and we have going continuously out to approaching infinity. And again, verbally, like this U symbol, that's union of intervals, and that's going to make reference to the linking word or. So you have, again, x is less than or equal to negative 8, or x is greater than or equal to 2. Right. And if we have, let's say, just in case if there's a run-in with Alex, say a problem of, say, like what we might have in the case of 52. And say we have the absolute value of 2x plus 7 plus 5 is less than 1. Right. So if I'm looking at isolating the absolute value of 2x plus 7, okay, so if I look at taking 5 away from both sides, so we have the absolute value of 2x plus 7 is going to be less than negative 4. Okay, so again we have the absolute value of x is represented by the absolute value of 2x plus 7, and k is represented by negative 4. However, k should be a non-negative value. Okay, and because of the negative sign that appears, okay, we're going to have no solution. So if you have a run-in like this, I know I have seen it in Alex, like among the options representing no solution, this would be like an O, or it's almost like a 0 with a slash that is going to go through. So again, whatever you have in the setup, if you've done the math around the process of isolating the absolute value term and your constant happens to be a negative, it might be that you've been doing the math correctly and you're starting to wonder, it's like why is this number negative? Or it might be because it's a trick question that's just asking for the participants to recall that k should be non-negative, and should you have that run in, well, as the problem might be designed, it turns out that there is no solution. Okay. All right, and let's say that if you have an inequality, say we have in number 60, okay, and say if we have a fraction. And we have in this one case, so if I have that, the absolute value of m minus 4 over 2 is less than 14. Okay, so this can be a case of where I have the absolute value of x is less than k is represented by this statement. So the absolute value term is already isolated, and if I were to split up, okay, so again, if I have that the absolute value of x is less than k and k is a non-negative value, then upon removal of the absolute value bars, you have negative k, which in this case is negative 14. It's going to be less than x, which I have represented by m minus 4 over 2, will in turn be less than k, which again I have as less than 14. Okay, and I'll just add in this description. So if I'm trying to remember if Alex had this particular exercise in terms of breaking up into and or statements, and if I had it like breaking up into like or and statements, this compound inequality would be in reference to m minus 4 over 2 is greater than negative 14, and at the same time m minus 4 over 2 is less than 14. Okay, so if you have your and statement, a lot of the and statements between inequalities can be consolidated into what's referred to as a compound inequality. And we have looking at solving for m, and we have in the setup, so I can get out of the fraction mode and multiply everything out by 2. Okay, so I have 2 times negative 14, and because I'm multiplying by positive 2, the directions of the inequality portions will remain fixed. So here we have in the middle, we're going to have the 2's to cancel out. And for that which is going to be further carried out upon removal of the fractions. So we have 2 times negative 24. 2 times negative 14 is going to be negative 28. And negative 28 we have is less than m minus 4. And that in turn is going to be less than 28. And just getting the m by itself. Okay, so if I add 4 throughout, so to isolate m in the middle, if I add 4 in the middle, I'm going to have to do the same thing to the opposing ends of this compound inequality. So we have negative 28 plus 4 So this will come out to negative 24. Negative 24 is less than m, and in turn, we have 28 plus 4 is going to end up at 32. And if I were to go ahead and express in interval terms, okay, now both, again, negative 24 and 32 are not included. And for the interval solution, okay, for the grouping symbols, because we don't have the equal signs, that means around negative 24 and 32 will be parentheses. Okay, so that'll be the interval solution outcome, okay, to what we have in the mix. All right, and tell you what, just for the next few moments, let's say if you're looking at determining the interval solution of, let's say we have I'll do it this way. Okay, so just for the next few moments, let's see what we get for the interval solution for these inequalities. So the absolute value of negative 2x is greater than or equal to 8 for the first, and then we have the absolute value of negative 2x is less than 8. Okay, just a couple of quick mentions. Okay, so we're looking at the same absolute value terms, as well as the same k value. Now, the first one we have absolute value of negative 2x is greater than or equal to 8, and this will be analogous to what we have in case number 4. Whereas the absolute value of negative 2x is less than 8, this can be analogous to what we have in the second case. And what we're going to do in terms of following through, and we have upon removing, okay, the absolute value bars. Okay, so we have, again, so absolute value of x is greater than k, so we're going to split up. We have, for the equivalent of x is less than negative k, and we have that negative 2x is less than negative 8, or analogous to x is greater than k, we'll have that negative 2x is greater than or equal to positive 8. And so we're going to have, in following through, okay, so if I divide by negative 2, okay, notice, okay, we have with division by negative. Okay, if I kept the inequality in the same direction, I would be making a mistake. So, once again, multiply or divide by negative, the direction of the inequality changes. And for greater than or equal to 8, if I divide by negative 2, okay, this time we are looking at, let's see, and my bad. Okay, so you have analogous to case number 5. Okay, so you have less than or equal to, okay. So you have upon breaking up, okay, so negative 2x over negative 2 is x, and we have is going to be, in this case, so we have greater than or equal to negative 8 over negative 2. So we're going to have that x is greater than or equal to 4, or we're going to have at the other end of the spectrum, we're going to have that x is less than or equal to -4. Okay, and so looking at what we have in the mix, okay, we have the values of concern. So there's going to be a little bit of crisscrossing. Okay, so you have -4, +4, x is greater than or equal to 4. Okay, you have a close point on 4, an array that's going to go out to the right. Approaching infinity, then we have at the other end for x is less than or equal to -4. Again, thanks to the equal sign, you have a close point, and this time you have an array that is going to go to the left. Again, drawing is not mandatory, but at least I do want to provide a visual, as well as safeguarding against any potential careless mistakes, and I was on my way to doing just that. So we have for the interval, so you have going from -infinity, approaching and including -4. So that is going to be in the bracket. And we have in union with the upper half that results. So we have going from and including 4. Okay, we have going all the way out to infinity. Okay, so this will be the interval solution here. Now, and looking at taking out the absolute value bars in this particular situation, now we're going to have that -8 is less than -2x, which in turn is going to be less than 8. Now, in taking care of the coefficient -2, okay, and with multiplication or division by a negative, we want to have both inequality statements or portions, okay, to change directions. So we're now going to have 4 is greater than x, which in turn is going to be greater than -4. And just writing from smallest to largest. Again, 4 is greater than x is same as x is less than 4. X is greater than -4, same as -4 is less than x. And if you notice, again, we're involving, okay, negative and +4. And with the lack of equal signs in the statement, so negative and +4 are excluded, but for what we have in x, it'll be those values that will lie in between. Okay, and so we're going to have for the interval solution, okay, once again we are involving negative and +4, and since neither of these limits is included, we're going to have parentheses exclusively around these terms. And now some key announcements. Okay, just some reminders. Okay, for the Alex homework section R6. Okay, again, that is due this evening. R8 is due Wednesday, February the 3rd. And just exercises, go ahead and be looking at, have page 113. Okay, and now for a key announcement. Okay, I'm going to have the first test up soon, and that will be listed as test 1 through Alex, and that will become available Friday, February the 5th at 12 p.m. The exam will have a 90-minute time limit and must be completed in one sitting. In other words, you cannot save your work and resume at a later time as you would like Alex homework. And the deadline for submitting this exam will be Monday, February the 8th at 11:59 p.m. Okay. All right. And I'll let this be our stopping point. If anybody has questions, I will stick around. Otherwise, we'll pick up next time on Wednesday. And here are the sets of problems from page 113 you can go ahead and be looking into as test 1 review.